NPV is a great concept that we can use to decide whether a certain investment makes sense or not. And we're gonna have a look at what it is and how it can be calculated. So let's start with a short definition. NPV stands for net present value. And this is simply the difference between the present value of cash inflows and outflows generated by certain investments or action. And obviously those cash flows will be from different points in times. So before we add them back, we, as it says, have to calculate the present value. It is used, as I said, for investments, but also to determine whether certain action makes sense or not. So you will see examples of that in later sections as well. So let's have a look at the example, but before that, a short reminder of the time value of money. So in the previous lecture, we said that nominal values are one thing, but you always have to rather look at the present value. And in order to calculate that, you need the interest rate. And on the basis of that, you can calculate the present value of those $100 that you get in different point of times. So the 100 that you get today are worth the 100. But the 100 in one time, they're worth actually only $95, and we get it by dividing the nominal value. So the 100 by 1 plus r to the power of 1. And when it comes to the 100 that we get in 2 years, they are just worth $91 in present value. And we calculate it by dividing the nominal value by 1 plus r to the power of 2. As you can see, what matters is the distance in time between the period from which we get the nominal value and today. Now, let's have a look at an example of a small investment where we have the following cash flows. So in year number 1, we have to spend $1,000, and then every year, starting from year number 2 to year number 5, we'll be getting $300. And obviously, the easiest way would be just to look at the nominal value, add them, and we would get some result that will tell us whether we are gaining more from those cash flows than we are spending. Obviously, this would be wrong because those 300 have different present value as they are from different period. And that's why before we sum them up, we have to calculate the present value. And using the previous formula, we simply divide it by 1 plus interest rate. So we assume this to be 5%. And then this is to the power of number of years between the year from which we get the nominal value and the year which is the present time. So between year number 2 and 1, there is 1 year of difference. That's why we've got 1 here. Year number 3, it's 2 years away from year number 1. That's why I have 2 here, and so on and so forth. So as you can see, we have these values. After we do the calculations, we'll get the following numbers. So the 1,000 today is worth obviously 1,000, but the 300 in 2 years is actually worth today 186. 300 in 3 years is worth 272. 300 in 4 years is equal to 259, and 300 in 5 years is equal to $247. And this, remember, is in present value, whereas those things above are in nominal value. So we can finally sum it up, and we get that actually this investment will help us generate $65 in 5 years. So we're gonna spend 1,000 in year number 1. And after that, we will get cash flows that in total will help us generate $64. And this is net present value. So as you can see, we started with the nominal numbers of the cash flows, which we've got in row number 1. Then using the formula we have introduced previously, we calculated the present value of each and every cash flow. As you can see, although they have the same nominal value, they will have a different present value. And once we sum it up, we get the net present value. So in other words, this will be a sum of all the cash flows expressed in a present value that a specific investment generates over a certain period of time. In the previous lecture, we analyzed an investment where we would invest 1,000 in nominal values, and then every year we would get 300 in nominal values in terms of positive cash flow. What we did was calculated the present value, which you have here, and then we discovered the net present value. So the sum of those present values for those 5 years is 64. Now the question is how we use the net present value in order to decide whether it makes sense or not to invest. And the general rule is very simple. So if the net present value is bigger than 0, then the investment can generate more cash than it requires. So this is something we can consider to be done. Below 0, it's eating away cash. So this is something that we may consider not to do. And finally, if it's 0, then we would look for different criteria. It neither destroys nor creates values, so you would need other criteria to decide whether it makes sense or not. However, you should bear in mind that the net present value can change. Let's go back to the example we had here. As you can see, what is given is obviously the nominal value. And then on the basis of the interest rate, we get the present value. So if the interest rate is different, let's say it's 10, obviously the net present value will change as well. Another thing that you should bear in mind is that the net present value is always calculated for a specific number of years. So the net present of value for 5 years will be 64. But even with the interest rate, if we do it for 10 years, it will be totally different because we'll have additional 5 years cash flows. So the net present value will change. So although the general rule is, as we said, if it's positive, then it means that you should consider the investment. And if it's negative, you should rather not do it. Bear in mind the net present value is not set in stone. So the net present value will, to large extent, first of all, this depend on the interest rate you're putting there. But second of all, it will depend on the time horizon you're analyzing. So for 5 years, it might be negative, but then for 10 years, it might be actually positive. So always take it into account. Now let's have a look how we can calculate the net present value in practice in Excel. So please open a file attached to the lecture, which is called NPV. And in the master sheet, as always, you will find a table of content. This time around, we're going to go to the second sheet, so NPV and IRR calculation for the investment. So here we have put in row 5 the data on our investment. So we know that in year 1, it will generate cash outflow. So we have to invest $1,000. Then starting from year 2, we're going to be getting cash inflow. So positive cash flow equal to $300. So this is year 2, 3, 4, and 5. And now we want obviously to calculate the net present value. So as we said, using the definition and the things we previously did, I can simply calculate the present value of each and every element. So 1,000 is equal obviously to 1,000, then 286 using the formula we have shown. Then the 300 we've got in second year, it's equal to 286 using the formula we have shown previously. In third year, the 300 is equal to 272. The 300 from year 4 in terms of present value is equal to 259. And the 300 from year number 5, again using the discounting formula, is equal to $247. And we've got the sum of this here. And that's how we calculate using the definition. As you can see, this method gives you the result. However, it takes a lot of time and it's rather time consuming. Therefore, we can use simply the formula NPV, and we have it here. As you can see, it gives us the same result. Just to give you an idea how fast it is, let's do it together. So we start by first getting the investments of the 1,000, and this is negative cash flow. We don't discount it because this is from year number 1. And then we discount the rest of the things. So we put the NPV formula like this. And here he'll ask you for 2 elements. So first is the rate. So interest rate, discounting rate you're going to use. And this is 5%. So I take the J15 cell. And then he asks us for the value we want to discount. And here I am going to use the nominal values of the cash flow generated by the investment. So starting from year 2, I simply do it to year 5 like this. You put the brackets and then you press the enter, and that's it. So very simple calculations. So as you can see, I got the nominal value from year 1, and then net present value formula I using the interest rate of 5, and then the nominal values from year 2, 3, 4, and 5. And this is how we got the net present value. As you can see, it's very fast. In the very same manner, we can calculate interest rate. So this is actually done in row 18. So it's equal to 8%. And as I said, it gives you exactly the same information as the net present value. So the net present value is positive. So this would suggest that the investment makes sense. Now, when it comes to interest rates, it's 8%. So it is bigger than 5%. So again, it makes sense to invest because we would get less money if we were putting it on a saving account or whatever alternative we use to calculate the interest rate, the discounting rate we use for the NPV. So both methods are fine. And when it comes to how you calculate it, we use the formula IRR. So you simply type it in, you get the nominal values, then you type the bracket, press enter, you have to format it at the end. And as you can see, we've got 8%. So the interest rate we got here. So it's very simple to be done in Excel. And this is what we're going to be doing over the whole course. So we're going to be using a lot of NPV. And I will not be doing this using the definitions as this done in row 8, but I would be using straightforward the formula NPV. So in the whole course, I'm going to be using this NPV to show you whether something makes sense or not. And in some cases, the IRR. I'll obviously not use the definition formula that we have in row 8, but I would use straightforwardly the formula for NPV and IRR. So let's move to complicated analysis where we'll have a look at investments and decide whether they make sense or not.